basic idea? How much is
Yeah,
there?
I know basics of quantum, like entanglement, superposition. I know all of that. A basic idea I have of quantum.
There's so many. I'll give you a couple of examples.
Yeah.
2 examples I'll give you. That will blow your mind.
Okay.
Okay? The fertilizers.
Yeah.
Okay? You know what is in the fertilizer? In the fertilizer, what we use? What is the main thing in the fertilizer?
On base of
No, what is the most abundant compound in the fertilizer?
potassium.
So this element,
Okay.
ammonia.
Ammonium. Yes.
Ammonia is what? NH3.
Yes.
1 nitrogen and 3 hydrogen.
Yes.
Because my chemistry is much bigger than your chemistry. I don't take this because I have not done chemistry after and I hate chemistry also. Okay, I think it's a magic. Okay, so I don't go anywhere near chemist. Okay, I stay away when I say chemistry. Okay, it's not like I don't know anything about chemistry, but this much I know. Okay, there's 1 nitrogen and 3 hydrogens.
Yes.
3 hydrogen, right? And nitrogen, there are plenty of nitrogen in the air.
Yes.
Hydrogen is also plenty.
Yes.
But do you know how much energy that you have spent to combine 3 hydrogen and 1 nitrogen? Any idea?
Around 1,000 joules.
Just forget about actual that number. 25% of world's greenhouse gas emission comes from that.
Oh.
World's. That much energy. When that much, you have to burn. Greenhouse comes from burning the fuel. That's how you get greenhouse gases.
To make ammonia.
Ammonia. That much energy is required to produce it. Okay. So a huge amount of energy goes in that. Okay. Because that is actually done in a very high pressure, high temperature process. Then only you can combine all these three together. 25% greenhouse gas is not. It's not a small amount.
Yeah, it's a lot.
It's huge. Okay. So if you think about that, 25% carbon dioxide we can cut. Okay.
With the help of quantum computers.
No, I didn't say that. Right? So now, but in your backyard, in your home, or you can go to any place, there is a nitrogenous bacteria.
Right.
It actually can make ammonia from nitrogen hydrogen. At room temperature, normal pressure, normal temperature. The bacteria can do it. How is it doing that? You don't know. And if you look at the whole process, well, how many parts I told you here? 3 or 4 parts, right?
Yeah.
There are something like close to 100 parts possibility how it makes. That means combinations of path is there. I mean, path means proofs or possible recipe that bacteria is doing, and we cannot figure it out. Because that requires like more than a year of Earth to figure it out for a classical computer. More than the age of Earth. For a classical computer to figure it out. That much complicated path is there. Okay? A rabbit and carrot, you can figure it out in 5 minutes.
Yeah.
That's because it's straightforward. But that process is so complicated that it requires billions of years to figure it out for a classical computer. Super fast supercomputer itself. Okay? But that can be done in a fraction of that time if people have worked out how much time it would take if there's a quantum computer. Because quantum computer can take all of this path at once. Photosynthesis.
Okay.
What is it?
The process of making glucose and oxygen.
What is the process? I mean, what is photosynthesis?
It's when the plant absorb with the help of sunlight produces glucose and oxygen. It's a chemical reaction.
When it produces glucose, right?
And oxygen.
It takes carbon dioxide and oxygen.
No,
Yeah.
It takes carbon dioxide
And produces glucose.
and oxygen.
Yeah, oxygen is a byproduct.
Yeah, it's a
Right?
byproduct.
Okay. So night time the plant does something, daytime the plant does something else, right?
Yes.
And daytime the plant emits oxygen, night time the plant emits carbon dioxide.
Even daytime it respires.
Yeah, that's what I'm saying. Daytime, but mostly the photosynthesis will give you oxygen out, right?
Yes.
Yeah? And night, that's why you don't want to keep plants in your bedroom.
Yes.
Because in night time, it emits carbon dioxide.
Yes.
It's bad for you. Okay, that's the reason why people say you don't want to sit under the tree in the night.
Yes.
Because mostly a lot of carbon dioxide, some beliefs, but okay, there's a lot of carbon dioxide it limits night. Okay, so now this process is much more complicated than the fertilizer story we just told.
Oh.
Okay, but starch has nothing, right? Just hydrogen, oxygen, carbon. That's what it doesn't have anything. You just compare it, you will get it. How does it compare it? Yeah? There's nothing, right? It's all rice is what? Rice is basically it's all hydrogen, carbon, and oxygen. Maybe some other elements in this trace elements. Mostly this is 90%. That's what it is.
Yes.
If I give you this supply, can you make starch? You don't do, right?
You'll need time to figure out.
Yeah, that time will be many
Yes.
billions of years.
Yes.
Okay, and the temperature will crash. You need a program to do that. What are the possibility? If I go this way, I hit that. If I go this way, I hit this process. If I go this way, or I go this way, path 2 and go this way, then you go this way. Okay, it's like a maze. There's a in Wisconsin where I did my postdoc. There is something called a corn maze. It's very popular. So you can go. We used to go there. You are allowed to go only in the night. It's a corn, and you create this maze in a cornfield, large cornfield. And you will be pushed into one, you have to pay for it, it's a game. And you are given a flash lamp, and you have to get to the other end. That's all it is. But you will trapped inside the corn maze for the entire night. That's what happens generally. Then somebody will come and they will pull you out in the morning. That's what it is. So that's it. If you go this way, that room, okay, you go this way, but then you can come back, then you will say, okay, did they come this way or that way? Then you go this way. Then you will get lost. Right? That's what's going to happen. So similarly, this was that many possibilities. There's no way that a classical computer will figure it out. If you just know how to make this thing process, right, then you don't need plants anymore. You can make your own, you can make a machine, okay, put there this temperature, there this one, oh yeah, you got wheat. Change a little bit of recipe, oh I don't want wheat, I want today rice. You get that rice. Because they have same thing, right? They have all carbon, there's nothing else, right? Only carbon, hydrogen, oxygen, that's what they have. I just need to change it to recipe, you get sambar, you okay, do that, you can roast the coconut a little, we do roast coconut for sambar in northern Kerala, you don't do it here. But here and whatever that other thing, they have only the coconut roasting number is only different, they're same. Right? Similarly, if you add this temperature, this pressure, this much amount of carbon dioxide or whatever it is, I get wheat today. Oh no, I bought rice, the temperature I get now rice, right? If I know the recipe, I can do it, right? But that's the problem, because you cannot get it. Because that much, so this is like, I gave two general examples, okay? Recently only, if you figured out how the birds migrate, that's a one technology. How the birds move, because you see this, migratory birds, right?
Right.
This year comes, next year, same bird will come. They have put a radio collar and they found same bird comes. But same bird they have figured, they have found Canada at some point of time, the same bird goes through. How do they track the path? When our plane gets lost, right? How are they tracking it? That's a quantum technology. It has something, there's a GPS in the beak. Okay, there's a quantum tunneling process happening. Yeah, some depending upon which way it goes, some they sense the Earth's magnetic field, and that's how it goes. The difference is the Earth's magnetic field. Yeah, they have sensor, quantum sensor. That's what we do. Dogs smell. Quantum sensor. These are all quantum sensor. We have, say, if you can figure it out, you can figure it out immediately where is cocaine or where is that. You can immediately figure it out, or what she is cooking over today, or you can figure it out from a distance. Okay, no, or we can tell. Okay, no, that ratio is not correct, because you know how dogs smell, right?
Yes.
How dog doesn't smell sambar. That's what I read. No,
Huh?
It smells the ingredients. That detail. I don't know if it smells some, but it can tell you what that has this and that.
Yeah, because
It can dissect that into that fine detail. How much are the numbers? That's sensitive. Okay? So all those things, these are technologically, if we understand all these processes, huge technological advantages for this, right? Like I told you, this photosynthesis and this ammonia synthesis, that's from Haber's process. Ammonia synthesis, okay? Haber's process, that's what, okay? So, Haber's mold process, Haber's, I don't know how to feel, it's in my chemistry. Okay. So now, similarly, there are so many processes which we don't know in chemistry. So quantum chemistry is the field, and solid state physics, condensate physics, basically quantum chemistry is the field which gets most benefited by quantum computing. It's not physics people. The chemists are the one who gets benefited. It's not a physicist. And storing information. Okay? Same way. Searching information. I don't know, but country has gained quantum supremacy as such so far. All of a sudden, there are only papers where they have proved quantum supremacy on a few qubits. So in that playing field, I don't think there is a huge difference between India and other countries. The moment we make that initial start, that we are still lagging behind. Then we are all on the same playing field. So India has to be. There's no option for us. And people like you are coming up, so we have to. It has to happen. There's no option, right?
Yes. In how many years do you think?
That's hard to say because I would say 50 qubit in 5 years is what the government is put now. Challenge. Okay. So I would say 5 to 10 years we can see some signs of that already. Already quantum communication and quantum, many of these things are already used in banking and other field. Okay. So already many of these things are already used for this. So that means it will take, may not be a lot of time, but I would say 5 to 10 years we should see some sign of it. Okay. I think it's not limited. There are. This is not like our team facing here or in India, globally, because we work the same equipment. We work similar material, and we work with better people. Our manpower is better than rest of the people. Our students work 24 hours. Okay, there they probably will work 9 to 5 and go for evening to for entertainment. But our students, so we have better manpower. Okay, but lot of these things are basically the material issues. Okay, that is global for everybody, not just only for us. Everybody is the same thing. So for example, I don't know how much you can digest right now, but say I was saying this cell phone has like a nanometer scale transistor, and there are many billions of transistors in one inch. Many billions, okay? And all those transistors need to perform the same way. They should be good. That when it's made, okay? That's not an easy challenge.
Yes.
Okay? But in quantum mechanics, because this is not just, that's not really, each of those should have same quantum state. You should be able to initialize the same state. You should be able to communicate with all those equally, everything. That technology depends a lot on the quality of the material. Okay? Material will have always defects and stuff. So some of those things are actually, the material issue is what normally being faced by all of these qubit people. So that is the main challenge I think the world is going to face. Oh, it's not a fabrication or it's not availability of equipment or anything. This is what's going to be the challenge eventually. Because if you need 1,000 qubits, all 1,000 devices, a qubit is a device eventually. It looks like a transistor. They showed you, right?
Yeah.
They all need to work the same way. Okay. That's not easy. That's what I guess even the National Quantum Mission also, one of the main focus on materials. That's why there's also another head called quantum materials. Okay, there's another head completely. They're dedicated for developing materials for quantum technologies. Okay. Country, as long as I get money, I can buy things. But that cannot sustain. That's not a sustainable model. So as a country, what we need lot of fabrication, lot of companies who makes the components, equipment in India. That is probably the biggest challenge India is going to face. Now it's already facing.
It's already facing.
Yeah, nobody is there to give you something which is, which works. Because I think that's mostly because of the market. Because the industry works completely on finance, economics, right? In here as such, in IISER there are no specific challenges to IISER as such. But in India, the main challenge is this, like what I was discussing when we visited the lab.
Right.
What makes any science or any is the people. And we need the right people to do right job. Okay? So here also, what eventually is not, money cannot give you a quantum computer. Okay, something new. Okay? Money can, and the government is actually pretty liberal in terms of spending for science research. Okay? Otherwise, you would not see any whatever we see nowadays. Right? They're doing excellently well. Okay? And new quantum machine is coming up. Everything is so good. Right? But only thing is we need the right people to do the right job. Okay? So that's the issue. The issue is, just like in Kerala, everybody is finding job in Gulf. Okay, or some other country, and we have to get people from other states to do our job here. Okay, that's easy, right? A similar way, in India, what happens is people think that getting a PhD abroad is the biggest thing, but that is not true. That is proved again now. It's getting more and more proven. That depends on how many qubits we make.
Right.
Okay, we hope that in the next 5 years' time we should have a computer that is 50 qubits. Research says some number to do something useful. Okay, we already had half 4 now.
Right.
4 qubits we already have made. But now there are so many things because it's not just like making qubit, how they communicate each other, how do you transfer information between them, a lot of technology comes in.
Right.
Since it's quantum mechanical, not classical is easy. Quantum mechanical means a lot of these things, the state of the system will be preserved, or decoherence issues are there, all kinds of other things come in. Okay, so but I think many things are we are still figuring out. But the plan is the next 5 years time, 50 qubits. That's what it is. That's the project.